Hi, I hope you're having a good day. This video is going to cover how to factorise expressions. So what does factorise an expression mean? Well, it means to sub out as much as possible, and the purpose of this is to neaten up the expression by putting it in a form that makes it easy to manipulate. So I'll show you what I mean by that at the end. So first of all, what can we sub out? So we can sub out these things called factors. You may have heard of them before. They are whole numbers that can multiply to make the number that we are trying to find the factors of. Okay? For instance, the factors of 4 are 1, 2, and 4, because all three of these numbers can multiply by some other number to make the number 4. The factors of 16 are 1, 2, 4, 8, and 16. And I'll quickly say this, quite important to note, any number that only has the factors 1 and itself is prime. For instance, let's have a look at some common ones. Okay, so 2, the factors of 2 are 1 and 2. 3 as well, 1 and 3. 5, 1 and 5. 13, for instance, 1 and 13 are the only factors. There's one number that's not included, and that is 1. Now it has the factor 1, which is 1 and itself, so you think it would be prime, but we don't classify it as a prime number. Okay, so we need to think about how to sub out now. So we've talked about what we can sub out. We can sub out factors, but how do we sub it out? Okay, so let's write an example first of all. Let's write 4x plus 8. Okay, so the reason that I've written 4x plus 8 and not just 4 plus 8 is because if it was 4 plus 8, there would be no point factorising this, because we can just combine that to make 12 anyways. But the point of factorising is to take out as much as possible, or sub out, from multiple terms. Okay, so let's have a look at the factors of 4 and 8. Let's choose 1, 2, and 4. There are factors of 4. And 1, 2, 4, and 8. They are our factors of 8. Okay? So we can sub out any common factors. Okay? For instance, they both share a 2. So let's sub out a 2. Now, how did I do this? Okay? Well, I've taken the 2 out, and then I have thought in my head, what do I have to put in this bracket so that when I multiply it out, I will go back to the original? Because if you multiply this out now, you get 2 times 2x, which is 4x, plus 2 times 4, which is 8. So I have done it correctly, but how did I do that? Well, I subbed the 2 out, and then I divided each term by the number I subbed out. As you can see, I subbed the 2 out, and I divided the 4x by 2, and the 8 by 2. Okay? So this principle works for all of them. However, are we done here? No, because 2 and 4 also share another factor. They both share the factor of 2. So I could sub out another 2. So I could go like this. 2x divided by 2 is just x, and 4 divided by 2 is just 2. But now I've got this complex looking thing, but all this means is just 2 times this, which is 4x plus 2. So what do we notice here? The number that I've ended up with on the outside is actually the highest common factor between the two numbers. It is the 4. And what I was trying to demonstrate here is that you can technically sub out whatever you want, but the optimal form, the one where you can't sub anything else out without getting fractions, essentially, you can get by subbing out the highest common factor, which means the highest factor that they both have. For instance, let's look at the highest common factor, sometimes abbreviated as HCF, of, let's do 20 and 24. Okay, 1, 2, these are the factors of 20, 1, 2, 4, 5, then we're going to have 10 and 20. Okay, factors of 24, we're going to have 1, 2, 3, 4, 6, 8. I'm going to continue below because I'm running out of space. Actually, I might be able to fit one more on there. 12. Actually, we can fit all of them. And 24. Okay? The highest common factor here is, let's have a look, 4. So we sub the 4 out. Let's just say this was 20x plus 24, for instance. We could sub the 4 out. 20 divided by 4 is 5, so we have 5x left here. And 24 divided by 4 is 6. Okay? And we can expand this out to check it. Always a good idea. 4 times 5 is 20x. And 4 times 6 is 24. So we have done this right. And as you can notice, 5 and 6 share no other factors, so we subbed out as much as we could. Okay, so now you get the idea. You're trying to sub out as much as possible. What if there are more letters? For instance, let's have a look at this previous example with the 20 and the 24. 20, that's not a very nice 20. 20AB plus 24ABC. Okay, so we know the highest numerical common factor that we have was 4. Okay, however, numbers aren't the only things we can sub out here. Any letter in there as well we can sub out. So is there any letters that both these two terms share? Yeah, they both share an A and a B. Okay, so let's sub out as much as we can. Let's take out the 4, the A, and the B. So in here, 20 divided by 4 was the 5, and then we also took the A and B out. Now 24 divided by 4 was the 6. However, we've taken this A out, we've taken this B out, but we still have the C left over. So this is what it will look like. And again, you can expand this out to check. Okay, so one more example of this is with powers. Okay, by powers I just mean the little numbers that are above letters or numbers. They're also known as indices, and a power means that number times itself, the number that is the power. That doesn't make too much sense. I should write an example. X squared means x times itself. As you can see, power is 2 and it's multiplied by itself. Okay? X cubed would be x times x times x, etc. Okay? Powers are quite nice things. So, let's have a look at this example. Okay, so immediately, let's actually make this plus a 4x, okay? So the highest common factor of 2 and 4 is a 2. And they both share, well, they both share x's. However, this one has 2 x's technically, doesn't it? X squared means this. However, this one's only got 1. So we can only sub out 1. So let's sub out the 2 and 1x. We're left with the 1 remaining x here after dividing 2x squared by 2x. And we are left with 2 here after dividing 4x by 2x. Okay, so as you can see, factorising is quite a nice thing. Now I'm just going to quickly show you a practical application and then I'll wrap it up. So, before, we know how to solve some simple equations, but what if we were trying to solve it for a letter, but that letter was combined with multiple terms, okay? So let's say we're trying to solve the following for A, okay? So we'll have 4AB plus 2A, okay? This could be equal to, say, 5. Well, at the moment, I can't just say A is equal to anything because I haven't got it by itself. I can't divide by anything currently. However, let's factorise this left-hand side. Highest common factor of 2 and 4 is 2, and they both share an A. So let's sub the 2 and the A out. In the first bit, we will be left with 2B, and in the second bit, we will just be left with 1, because 2A divided by 2A is 1. In fact, anything in the world, n can be whatever number, whatever you want it to be. If you divide it by the same thing, you always get 1. Okay, so why is this useful? Well, now, as you can see here, we have got the A term by itself here. So I can divide both sides by 2b plus 1 And I get 5 over 2b plus 1. And now I can divide both sides by 2 to get a single a. And we get a is equal to 5 over 2b plus 1 divided by 2. And I will make videos on how to manipulate equations like this and how to do arithmetic operations with fractions, which basically just means add them together, multiply them, divide them. But for now, you're going to have to trust me here. This is the same as doing this, which is 5 over 4b plus 2. And as you can see, we have now got a by itself out of an equation that had a in multiple terms. And that just about covers everything you need to know with factorising. Obviously, like the other topics, the only way you'll get good at this is if you practice. We will do some questions on it. And yeah, have a great day.